Hey guys, welcome back to Ox Tools. I'm Tom. So we showed the surface grinding video the other day where we were grinding the rough grinding the what's in your box toolmakers vise that Keith actually presented recently. So due to timing and circumstances, we ended up doing some of the rough grinding up here and a little bit of the finish grinding. So what you guys saw in the video was really the rough grinding, and at the very end of that video that I put up, I had done as much of the finish grinding as I could do before I needed to send it back to Stan. So like a lot of things, there is a difference between roughing and finishing, and this generated a bunch of really good questions. You guys put up some really good questions, so I thought it was more appropriate to capture this information in the form of a video than it is to just put it in the comments and kind of bury it in the comments. So anyway, let's talk about some of those things. I wrote down a list of questions, and the first question is, are Stan and Chuck giants? And the answer is yes, they are. They're big guys, a lot bigger than me. I wasn't standing in the hole. Those guys are Clydesdale class, or I'm just a little baby buffalo class. So anyway, yeah, they're big guys. So the next one that popped up was somebody asked, what's with the paper back here? And actually I need to change this, so I'm going to go ahead and change it and explain what this paper's for. Oh, it's actually a drawing. How do you like that? What this paper does is it gives me a white background, and when I'm picking up, when I'm bringing this down to pick up a surface, if I look in this direction here, and I have a nice white background that gives me a contrast with this space, and believe it or not, I can dial that in to less than 1/10. And that way I get a decent pickup. You don't want a heavy pickup when you're doing grinding work. You have to basically creep down on it until you just start making sparks. So the closer you can get that initially, the quicker you can get going. And sighting along this direction is an easy way to do that. And the other thing I do, let's see, where's my, is I have a little light, and it's one of these Larry lights. And so I put that Larry light in here like this, and it makes that paper bright white so that I get a good visual through there. So I'm going to put a new piece of paper on there because that one's getting a little funky monkey. All right, and I just hold it on with a magnet. Okay, and you can see, hopefully you can see how bright that is. And so I'll move the camera and I'll try to get a shot along there between something, and you guys can get an idea of that little space that we're looking at there. Okay, so let me switch the camera and I'll do that. Okay, so you can see this. You can see the light through there, right? So you can see between the piece, and I'm going to bring the wheel down, and we're going to bring it down, down, down. And you can see that gap just closing up right there. Okay, so that's probably an excellent pickup right there. And it's not touching yet, but it's pretty damn close. Okay, so that white background back there really makes it easy to see that space. And so that's what the white paper is about. And yeah, sparks hit it, but the sparks are not very heavy compared to hand grinder sparks, so it's not much danger of it igniting or anything goofy like that. Okay, so one of the other questions that came up too was, when we were grinding the vise, we started with the backside here, okay? And somebody said, hey, why'd you put it in another vise, right? Why didn't you just put it right on the magnet? Well, you're starting to get the idea here is it's got this big L shape, right? That is not a suitable datum to grind that bottom, okay? Even though it might hold it, yeah, that's not enough holding power to do the grinding on the bottom, okay? Well, you know, somebody said, oh, well, just put it on the chuck. Well, when we hang it over like this, okay, yeah, sure, that sort of works, okay? But it's sitting on one of these screw heads, and I don't have that much travel to get off at the end. So I need to be in the envelope here, in that region, okay, to do that grind. So the other possibility is putting magnetic parallels, you know, or magnetic transfer parallels under here. The problem with that is they don't work that good over a long distance, okay? So yeah, it kind of works, but it's just not enough holding power, in particular for how much we were roughing off of the bottom of that. So during heat treat, that thing had, let's see, did it go that way or was it that way? I don't remember which way it was. I think it was hollow in the middle. That's right. I think it was hollow in the middle because it hit on the edges first. By 6/1000ths, right, I think was the number. That's a lot to come off on a surface grinder, okay? It's, you know, we probably should have belt sanded it a little bit first, but we wanted to play with the grinder and we were having fun, so it was all good. So that's why we put the vise in another vise to do it, because this is not a good way to hold this. It's not a stable way. You know, your stability, your setup, and the ability to pull it in and out of the machine so you can do measuring and in-process measuring is really, really important. The grinder teaches you about controlling your datums and repeatability. Because when you're working in real small numbers, you know, fractions of thousandths of an inch, right, or handfuls of microns for our metric viewers, everything counts, right? You know, specks of dust, your setup, little burrs, everything matters, okay? So you have to be methodical and very, very careful about your work, okay? So anyway, that was the reason for not putting it right on the chuck. All right, let's see what else we got on this list. All right, so somebody else asked, they said, hey, you know, if I want to make one of these vices myself, you know, could I use mild steel and would that work, right? And the answer is sure, it would work, okay? The reason that we make things out of hardened steel is durability, okay? So wear resistance, okay? So when we slide these things around, right, and we use them, right, on the machine, that we're not wearing material off. They retain their accuracy when they're hard, okay? They're more stable. They don't get dents in them and nicks and things that affect their how they sit on the machine. So sure, you could make this out of soft steel and it would work fine. The only problems that you might have would be with the moving parts, where you have two materials of the same hardness rubbing on each other. That's never a good situation, and I can't think of an example where that is a good situation. Let's put it that way. So heat treated materials are more stable and they last longer and they don't wear. So that's why we make gauges and durable tools out of them. Okay, so like, you know, this guy here. So this is, you know, a surface gauge that slides around on a granite plate, right, or on a machine table or whatever, right, it's hardened, okay, so it stays flat. Now, interestingly, there are plenty of examples of things that are soft. This chuck is not particularly hard, you know. That's one example, and then the table on your milling machine or your something like that is not super hard. Okay, you can easily mark it with a drill or dropping something on it or whatever. So you know, this is why we keep stones around, you know, to to take any little nicks or burrs off of these surfaces, so that we have good, smooth, clean datums. Okay, and you know, I know what everybody's going. Hey, if you rub a stone on that, you're going to wear that out, right? Well, it's basically the weight of the stone. I'm not pushing down on that. I'm just rubbing it back and forth, you know, and if there's any high spots, it'll just kind of knock those off, okay? And, you know, you periodically regrind this, the chuck to maintain accuracy, okay? And then this stone here, I lap this so it's real flat too. So, and there's a way to do that. So you don't want to use a wavy stone, okay, or else it'll put waves in whatever you're rubbing it on. So your stones need to be nice and flat too, okay? Or they need to be thin ones. Some guys use the real thin ones, and they kind of do the same thing, and it's with a thinner stone. So okay, all right. So the next big one, the next big question was, hey Tom, how come you weren't using any coolant? Okay, and that's an excellent question. So and there's a lot of these things are personal preferences. Coolant makes a mess. Okay, it makes your grinder a mess. You gotta clean it after you're done and dry it up so that things don't rust. And yes, it can help with reducing heat. That's its primary function, okay? The part that we were doing, we were rough grinding that, okay? So, and it was a big, massive part. So heat buildup, yeah, it was getting warm at times, but basically we really wanted to get it reasonably flat and then go back for finish grinding. Now, I do have a coolant set up, and so there's dry grinding, which is completely acceptable, okay? For small parts, this is, standard procedure, okay? This has the ability, I can pump coolant in, and then I have another one of these shields that's got a nozzle that comes down along the wheel. So yes, I could run flood coolant. So you can do dry, you can do flood, you can do mist, which is I think what Stan uses, mist. Now he's grinding thin parts where heat, they're very sensitive to heat, okay? And what happens when they heat is they pucker up, and then you grind, and then when they cool off, they sink down, and you end up with a hollow in the middle, okay? The last one is the one I use, and it's air, okay? Let me pop this off, and what this is here this is a cold air gun, and it fits right like that. And I can put it up nice and close like so, and not touch the wheel. And you run compressed air through this, and it has a little venturi, and very chilly air comes out of there, okay? So it cools that interface between the grinding wheel and the work, and does a pretty good job of it, and it doesn't make a huge mess, okay? Now, it makes more noise, and uses compressed air or whatnot. So if I'm doing a thin part, I'll use air myself. That's my preference, okay? So big grinders that in commercial grinding operation, they're all flood coolant. Keeping the coolant super clean is really important to getting good finishes and things like that. So if your machine's set up for coolant, by all means use it. And but you can do a lot of grinding dry or with air or with other methods. And in some cases, you can actually just spritz it on. You just need a little bit on the surface to keep things cooled off. Okay, so by evaporation. All right. Okay, so let's talk about wheel degradation. Okay, so a couple of guys said, hey, how do you know that your wheel's the same size that it was when you started? It's wearing away, and you're right, it is wearing away, okay? But it doesn't wear the way you guys might imagine that it wears. It doesn't wear much on the diameter. Where it wears is on these edges. So the way we use the wheel is we start off of the piece, we down feed down, and then we come over. So if this is a material that I'm grinding away, I'm coming at it like this. I'm coming at it with this leading edge here, right? Okay. So what happens is that leading edge, and also that one, if I down feed and come back across, right? It wears at it. I don't have a good way to show you here. I'll use a scale. So it wears like that, okay? So this leading edge, if this was my leading edge, wears away, okay? So this thing ends up slightly angled, right? But as we're plowing that material off, what's happening is this is doing the brunt of the work, and then back from the edge is doing a little more work, and back from the edge a little farther is doing a little more, until finally we have the lightest of the light cuts on this back edge, or the middle, depending on if you're going both ways, that is sparking out, okay? So that's how you're supposed to use it. You basically push this material off with the leading edge, and then as that spark trail goes across the wheel, it's sparking out, okay? So, so that part that's sparking out is really just cutting a tiny, tiny amount, so it preserves the diameter of that, okay? Now, if you're coming straight down and using the full width of the wheel, you're absolutely right. That would wear the diameter very quickly. But these small grinders really are not big and heavy enough to do that. If you have a big monster grinder, you can do big step overs. And depending on what you're doing and how much you're taking off, you might use the entire wheel width, okay? So it just depends what you're doing. There's a lot of operating parameters with grinding, in particular when you get into big stuff. And so anyway, that's how the wheel wears. So it doesn't wear on the diameter so much, it wears on the edges, okay? And this is what we were doing too. Was a slightly, I wouldn't call it an oddball technique, but it's a technique, we're taking an aggressive down feed and a small step over, so that leading edge is wearing away. So yes, your spark trail is back from the edge, right? And it continues to grind back from that edge as you move over, okay? So because the wheel is it's not flat, okay? It's got an angle to it from the wear. And as the wheel breaks down, that's the idea, the wheel's breaking down, it's exposing fresh abrasive, and it continues to cut. So you need to think of this like not as a grinding wheel, but more like a giant end mill, okay, with a lot of teeth, okay, and then the teeth are very small. And if you look under a microscope at the swarf that comes off, okay, they look like chips off of the lathe. They got little curls and they're little tiny chips, okay? So I remember the first time I did that and I looked at that, I went, oh my God, and it completely made sense, right? That these are actually flutes, you know, it's got zillions of them, but they're actually like flutes of an end mill, and it behaves the same way, okay? Now, the reason they make sparks is because they're so small and it's moving so fast and the abrasive is so hard that they get heated, and that's why they glow and fluoresce like that. So, okay. So anyway, that's a little bit about wheel wear and why you can go across a large surface like that and not have your size change much as you're grinding. Okay, so another one of you guys asked about the direction, the cutting direction, okay? And you're absolutely right. The wheel spins this way, okay? All right, so we'll just put a big arrow on there to remind, big funny looking arrow to remind you guys, okay? So the wheel's going that way. So depending on which way I'm traversing the table here, I'm either climbing or conventional grinding, okay? Climbing, conventional, okay? So, yeah, there is a difference, but typically with grinders, we're cutting so small that it doesn't make a lot of difference, okay? Now, when you get into really, really fussy stuff, some guys may only climb to do the finish, or they may only conventional to do the finish. So you have some options, right? So there's what we call Let me move this out of the way here. So I guess you can see this. So you can do what's called a zigzag like this, right? Which is basically we're going back and forth and then traversing this axis each direction, or you can go and then come back and then move over, go, come back, move over, go, come back. So you can do that. So, you know, there's a bunch of different kind of patterns that you can use, right? Most guys kind of use the zigzag. It's pretty common. The things that vary are this amount of step over here and this traverse speed. Okay, those are some of the tuning knobs that you have to play with on the grinder. Okay, so you know, for most grinding, it doesn't make any difference whether you're climbing or conventional. You know, when you get into super fine finishes and things like that, or you're doing round parts, right? It makes a difference on doing round parts. Okay, so that's Tom's 2 cents worth on climbing conventional grinding. So I hope that made sense.